Good day, it is Stephen Davids here, and in this video I will discuss how to find boundary lines and pegs. For example, you will need this when you want to build a fence. The first tip is that you can ask around from neighbors. Maybe people built and during the building process they saw actually where the pegs are. I did ask around here and people could not help me, but it was a good starting point. I asked from the municipality, since then I will have to look for the pegs. How deep is it, more or less? In our case, they told me they can't specify what depth it is. It can be 500 millimeter to 1500 millimeter deep. You start with the building plan. Use the approved building plan because the fact is that it was approved in terms of the distances from the boundary pegs, and that will give you a very good fixed point. Now from the looking at the plan, you will see then also can determine where will be the number of the exact locations of the pegs, as well as the number of the pegs. In this case, it works in a straight line, A, B, C, and D. Those were the pegs I needed. I did not look to another peg. You start with then get fixed coordinates for some pegs. In the case of the corner peg A, the boundary line of 5 meters from Seaview Drive, as well as 1500 from the neighbor. In the case of D, peg D, 5000 millimeter boundary line from the street, Diza Street, as well as 2080 meters from the other neighbors. So those are the coordinates that I could use. I also used coordinates for C, and this coordinates I got from another section of the plan. Since C and B are at a corner that is at a triangle, I then used those additional information to determine where B and C will be. B is 5000 meters from the boundary line, plus the 2291 centimeters that is part of the triangle. So if I then measure from the side of the house that 729, I will get to B. If I get to C, C is then 5000 meter from Diza Street, you see there, as well as I take the gap into consideration. And if I have those issues in a straight line with the house as one side of the house, then I will get point C at 7291 millimeter from that corner of the house. You go further and then you try and create or get additional points, reference points. The more the merrier. And the fact of the matter is that the more reference points you have, the easier it becomes, and you have more certainty there is the peg, especially if you go out and look at what's going on. So for A, I got the additional angle, the square root of the side of one of a triangle. I use that square root plus the other square root sum. I use the same sum to get the additional side of the triangle. For the point D, I calculated the power of 2 plus the power of 2, the square root thereof. point B and C is given on the line as 7.00 meters, so that gives me another additional point. If I get C, then I can measure that to B, or if I get B, then I can measure that to C. So in essence, it boils down to the fact that get as many as possible reference points. I then try also to construct another point where I used two boundaries. One boundary line is 20 and the other boundary line is 25 meters. So if I take this as a rectangle and I just add, if I find one point, if I add another 5 meters, then I will get, or if I add that, maybe from point A I measure that 25 meters and I get another point, and from that ultimately the point that I construct at the end of the constructed rectangle, if I measure back with 5 meters, I'm also supposed to get by B. I use the same thing with C. I calculated the one boundary opposite is 21 meter, and the Giza Street is 16 meter. So if I just add 5 meters, should I get 0.5? 5 meters from that I can get an additional point, or from point D I measure, if I get the peg at D, just measure 25 meter, and from that 25 meter move back 16 in a square back, or alternative just 16. In essence, as I said, the more points you get, the better. Then of course the day is, you can't only sit at the desk study and do desk studies, you must get the tools. The tools I used was a measuring tape and a boulder square, and then also an assistant to help me. You get also some wooden picks just to help you, and a hammer of course, and a spade, because you will need a spade to dig for the pigs. I first then went out and draw a straight line to get use the distance from the house as a reference point, and I measured a straight boundary line. There is a straight boundary line. If I of course found the end pegs, I can just use a boulder's line, but at this stage I did not get the pegs, boundary pegs. I had to look for it, and so I established first a boundary line. That was the easiest to measure out. It's long, it's just the distance from the house. Then I made some additional physical reference points, construct them. To construct them, I put them in, and here is also where I then used from the triangle, constructed the triangle and completed the square of the house. I completed the square of the house, and from that square then I measured 5 meters to the one side, 5 meters to the other side, and that helped me then also to determine where the pegs are. As I said, the more reference points you have, the better. Ultimately you must start to dig for the points, and I started with the points where it is easier, and then move on to the next one. The fact is then, if you do not find one, you will move on to the others. I started with A, and then B, and then C. That was what I thought. I thought originally I will start with A, B, and C, but when I went to the physical structures, I see, according to my calculations, the peg in A is either underneath or extremely close to this big pole there, and because this pole has some sentimental value for my neighbor, if it is underneath, I did not really want to go there from on the very start. I then went to D, dug some 1 meter around, did not find it, and then ultimately I had to go further. I then came to C, dig around 900 centimeters. The ground became very hard. I had to stop. So now I had 3 points where I thought it was, and I didn't find anything. I went then to the 4th point, and lo and behold, it was exactly on the calculated spot. It wasn't too far, too deep, so I found immediately C, and from C then I decided now I can work. I've got this fixed reference point, additional fixed reference point to the house, and I can work further. At this stage, I must just say it's good to stay in contact with people who know more. I found people, man, am I correct? It's now very deep. I got someone from the road, even at some stage, but if you can know people that knows the area, it's good to stay in contact with them. I moved then to point back to A and D, and then the essence is if you dig deeper as well as increase the circumference, then you have a great thing on finding them. I found then A and D. A I found exactly where I calculated it. I said it's either underneath the pole directly next to the pole, one pole, it was. D, it was about 10 to 15 centimeters off my calculations. Although then I went in at C and I dig very deep, nearly a spade's depth is 900 millimeter, until I reached a spot where I couldn't go through because our ground was very hard. And I dug a wide thing. After consulting people, they said, no, this side, no, that side. I did do my calculations exactly, but you must also trust people who are in the area and know things. They said maybe the house was off, so I just dig, as you can see, maybe some around 1 meter circumference, and very deep also, and I didn't find anything. So I had to get the surveyor in. The surveyor confirmed that the peg was removed and he put in a new one, and in fact he confirmed also that my calculation in terms of this point C was spot on and correct. Lessons learned is that the calculations from the plan is important. That is your first reference point. You must get as many reference points as possible. Stay in contact with people who has the know-how what to do. And then it is not always a straightforward case. Maybe it will be, but it's not always a straightforward case of getting your measurements, and then there's your pegs. It's more back and forth movement from one peg to the other, and systematically you have to dig deeper and wider. And lastly, sometimes you must just accept a peg is not there, but it is removed. This is Stephen Davids, and I thank you very much for watching this video. Please like, share, and subscribe. Thank you very much.